Welcome to our session. This is the first session, Big Data Application. And we have I'm Jie Wu from Beijing University. In this session, we have 4 papers to be presented. The first one is real-time event detection in Sina Weibo. And the second one is a feature set for streams and a demonstration on high-frequency financial data. And third one is the value of using open source scalable technologies for social science and social network analysis. And the fourth paper, although we are still finding the authors, is using Hadoop to implement a semantic method of assessing the quality of research medical data sets. Now, let's welcome the first presenter, Ms. Jiafan Zhang, to present the first paper.
Thanks for the introduction of the chairman. Good morning, everyone. My name is Zhang Jiafan. I come from Northwestern Polytechnic University in Xi'an. Today, I'm very glad to be here to show our work. Our work is about event detection in Sina Weibo based on trending words. Next, I will give the presentation from the following 5 parts. Our work is based on Sina Weibo, that is Weibo.com, and it is a Chinese version, Twitter. It is an example from Weibo.com. As you can see, it is similar to Twitter. It has the publisher, hashtag, URL, emotion, and interaction. Weibo.com is one of the most visited websites in China. And this picture shows how popular is Weibo.com. And according to the statistics of 2012, there are about 503 million users registered in Sina Weibo, and there are over 100 million messages posted each day. As a result, Weibo.com provides us with a huge amount of the macroblogging data. So next, let's see some characteristics of the macroblogging data. First, the content of each macroblog cannot be more than 140 characters, and the informations are updated in nearly real time. And second is the unique simple discourse structure of the macroblogging data. Third is the machinism of the macroblog, for example, including post, repost, comment, hashtag, mention, and URL. And the macroblogging data provides us with very fresh news from human sensors, which makes Weibo a timely, fresh information resource. And the most important is that event detection from Weibo streams would help us in timely understanding of users' opinions with respect to the detected events. However, detecting events from Weibo streams is still challenging. There are 3 main reasons. First, the content from Weibo streams are very noisy. Second, the topics of the macroblog are highly diverse, and they are changing fast. Third, there are a large amount of data with huge data rate, and there are many irrelevant messages and many redundant messages. Next, I will talk about the related work. Recently, event detection in microblogging social networks, especially in Twitter, has become a hot research topic. As we observed, most existing approaches are applicable to certain types of tweets. For example, tweets having specific hashtag containing a predefined entity or related to disasters. And other solutions involve complicated processing. Furthermore, there is little work focused on how to detect events in time from microblogging streams, which affects the availability for event detection from online content generated by users. And besides, there have been some researchers studied the event detection with Sina Weibo, but we are the first to systematically study the event detection with Sina Weibo. Now let's see some basic concepts in our paper. First, what is an event? According to the Cambridge Dictionary Online, event is anything that happens, especially something important and unusual. Here we define a realistic event E expressed by a set of words, as this formula shows. E consists of the core word set CE and the subunit word set SE. The core words are representative words of an event, which take a high probability mass over the words emerged in a certain time interval. And the subunit words are words co-occurring frequently with core words. This picture is an overview of our event detection methodology. And there are three main parts of our methodology. The first is core words detection. The second is subunit words detection. And the third is clustering on candidate events. Next, I will introduce these three parts in detail. First is core words detection. We used an approach in a dynamic manner, which is similar to temporal TF-IDF. And the word score in our algorithm is defined as WSW, as this formula shows. In this formula, FCW is the frequency of the word W in a current time interval. And the FBW is a basic frequency of word W across multiple time intervals. And the word and the high WSW indicates that the word W have a high frequency in current time interval and regular across multiple time intervals. Now let's see the discovering core words algorithm. First, we rank the words according to their WS scores. And then we set a threshold alpha to determine the candidate core words with high WS scores. Finally, we select the top few with highest DF scores as core words Here, the DF is document frequency. It is easy to get FCW, but how to get FBW in an effective way? Here, we proposed an iteration formula to determine the basic frequency FB. In this formula, the lambda indicates the decay factor, and it is inspired by the other researchers' previous work. That is, most online content obey exponential rise and powerful law, and here we adopt the powerful law as the decaying curve of the probability of the words. For subordinate words detection, we aim to discover subordinate words in terms of high co-occurrence with core words. And here we examine the co-occurrence of the word W with core word C by leveraging the conditioned probability PWC, and which is determined by calculating the document frequency. For clustering, there are three main steps. First is LD modeling. Second is GSD measurement. And the third is agglomerative clustering. And this picture shows the procedure of the clustering. First, we organize each core word and its subordinate words as a document. And each document represents a candidate event. And then we use the LDA framework to map each candidate event into a feature vector, which is represented by a set of probabilities over the entire bag of words sourced from candidate events. And finally, with the GSD as a distance measurement, we adopt agglomerative clustering to find meaningful clusters. Now I will talk about our experiments. First is the data set we used. This table lists some basic statistics of the dataset we used. And this figure shows the post distribution. And here we select the Weibo posts published from July 2012 to November 2012 as this time frame involves the most post volume. And before experiment, we do data pre-processing. There are two steps. First is free segmentation, and the second is stop words removal. For evaluating FB, we adopt RMSE and CV-RMSE to evaluate the accuracy of FB. Now let me do some interpretations of RMSE and CV-RMSE. RMSE is the root mean square error, and the CV-RMSE is the coefficient of variation of RMSE. It is defined as a RMSE normalized to the mean observed values. And as these two figures shows, both RMSE and CV-RMSE clumps up as the number of days to estimate increases. That is to say, it is difficult to evaluate the FB of those long-run poppers. However, the long-run poppers are very real. So for the relatively short period, the performance is acceptable. Now let's see some case studies. This is the first case. The finger on the left is the clustering results for the first case, and the x-axis represents covered ID, and in the list on the right maps the covered ID into the exactly meaningful word. And according to the clustering result, we got this table. This table is a description of the event detected by our method. The first column is call words. The second column is subordinate words. And the third column is a description for each event. And from this table, we make two observations. First is many detected events contain multiple call words and subordinate words, and it is easier to interpret the events described by the words in multigram. For example, the event described by the fifth line is much harder to interpret when compared to the event described by the first line. And the second observation is that the detected events cover a wide range of events. From sports to nature disaster. And as the topics of microblog are highly diverse, there are some events are not related to real life. For example, the event divided by the first line, it is not a realistic event. And this figure shows the performance of our method. In this in terms of precision and recall, and the blue bar represents the precision, and the red bar represents recall. In this figure, we can see that for some events, event number 2, event number 1, event number 3, and event number 5, they are all the precision and recall are very high. But for the others, the performance, especially the recall, are not very well. And this is the second case. The meaning of this figure is similar to the first case. And this is the table, shows the events detected by our method for the second case. And this figure shows the performance of our method for the second case. As conclusions, we propose an effective method on discovering birthday keywords for streaming data by taking the social dynamics information into account. And we utilized the LDA with the similarity among the candidate events detected and the agglomerative clustering method to generate the compact form of the events. And in the future, we will systematically take the temporal and social context into account in order to improve the image detection performance. And we will investigate the methods on identifying the real-life events. That's all. Thanks for your attention.